January 12th, 1945. Aberdeen Proving Ground, Maryland. Temperature hovering just above freezing. Engineer L. R. Price stands in the test shed, staring at a problem that shouldn't exist. In front of him sits the first T26E1 Pershing tank ever built, serial number 01033292. Except it's not a Pershing anymore. Mounted in its turret is a gun barrel so long it extends nearly 11 feet beyond the front of the hull. The 90mm T15E1, 73 calibers in length, almost twice as long as the standard Pershing's gun. This weapon can punch through 8 inches of armor at 1,000 yards. It can penetrate a Panther's frontal plate at over 1.5 miles. During test firing, its shells went completely through a captured Jagdpanzer IV and embedded themselves in the dirt behind it. There's just one problem. The turret can't handle it. The gun weighs so much that its barrel droops toward the ground when the crew tries to elevate it. The gun mount, designed for the shorter M3 cannon, simply wasn't built for this kind of weight. The turret is muzzle-heavy by 140,000 inch-pounds. Without some kind of counterbalance, the gunner can't elevate the weapon. The tank is useless. Price has 3 weeks to fix this, not 3 months. Not 3 weeks for design and 6 months for production. 3 weeks total. Because across the Atlantic, American tankers are dying in machines that can't reliably kill German heavy armor. The M26 Pershing, with its standard 90mm gun, is good against Panthers and Tiger ones. But the Tiger II, the King Tiger, is something else entirely. Its 88mm WWII 43 outranges and outpenetrates anything the Americans have, and the Pershings are struggling. So Army Ordnance did what desperate organizations do. They took the first T26E1 prototype, the very first Pershing hull ever built, and told Wellman Engineering Company to install the longest, most powerful 90mm gun they could develop. Never mind that the turret wasn't designed for it. Never mind that nobody knew if the mount could handle the recoil. Just make it work. And now it's Price's job to figure out how to balance a gun that's throwing the entire turret off its center of gravity. The solution he comes up with looks insane. 2 massive external spring assemblies, each one mounted outside the turret on top of the gun mantlet. Coil springs the size of a man's torso, visible to anyone looking at the tank. They stick up like rabbit ears, completely exposed to enemy fire. Every engineer who sees them has the same reaction. That can't possibly work. And even if it does work, those springs will be destroyed by the first enemy round that comes near them. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Price doesn't care what it looks like. He cares that it functions. The external springs provide the upward force needed to counteract the gun's muzzle weight. They're equilibrators, devices that balance the load so the gunner can actually elevate and depress the weapon without fighting against hundreds of pounds of barrel weight. With the springs in place, the turret crew can operate the gun. Without them, the T15E1 is just an expensive piece of sculpture. Testing begins on January 12th. The tank fires its first shots later that afternoon. The external springs work. They hold the gun's weight. They don't break. They don't interfere with the gun's operation. Price's ridiculous solution is functional. But functional doesn't mean good. The springs create problems nobody anticipated. They're mounted externally, which means they're vulnerable. 1 piece of shrapnel, 1 stray bullet, and you lose your gun balance. The springs also limit the gun's maximum elevation. You can't point the barrel as high as you could with a properly designed internal system. And they're a maintenance nightmare. Springs exposed to weather, to dirt, to the constant vibration of tank operation are going to need replacement constantly. Army Ordnance looks at the test results and makes a calculation. This tank, this hybrid monster with its too long gun and its external springs, will never be a production vehicle. The T15E1 is already being replaced by the T15E2, a redesigned version that uses 2-piece ammunition instead of the unwieldy 50-inch single-piece rounds. Production T26E4 tanks will get internal hydropneumatic equilibrators, properly designed mounts, and better weight distribution. But none of that will be ready until late spring at the earliest. And the war isn't waiting. On March 1st, 1945, the Ordnance Committee formally approves this prototype for service under the designation Heavy Tank T26E1 Pilot Prototype No. 1. One tank, the only one that will ever be built with this exact configuration. Sending it to Europe. The reasoning is brutal and practical. American forces are pushing into Germany. They're encountering dug-in Tigers and King Tigers in defensive positions where those tanks' superior range and firepower are devastating. The standard M26 can handle most threats, but against the heaviest German armor in fortified positions, American tankers need an edge. The T26E4's gun can provide that edge. Even if the tank itself is a mechanical compromise, even if the external springs are vulnerable, even if it's an ungainly prototype, it's still the most powerful anti-armor weapon America can field. On March 15, 1945, the T26E4 Pilot Prototype No. 1 arrives in Europe. It's assigned to the 3rd Armoured Division, one of the most experienced armoured units in the European theatre. But before it reaches a combat unit, it makes a stop at the division's maintenance battalion. This is where the tank's appearance gets even stranger. Belton Cooper, serving with the 3rd Maintenance Battalion, watches as the experimental tank rolls into the motor pool. Cooper will later write a memoir about his experiences, and he'll take credit for what happens next. But according to official records, the modifications are actually directed by L.R. Price, who's travelled to Europe with the tank. Price is the one who decides the prototype needs additional armour protection. Because that T-15E1 gun and those external springs won't matter if the tank gets knocked out before it can fire. The maintenance crews get creative. They salvage armour plates from destroyed German Panthers. Specifically, they cut sections from Panther frontal plates, 80 millimeters of sloped armour designed to deflect shells. These plates get welded onto the T-26E4's turret mantlet, adding significant protection to the gun mount area. Then they add boilerplate sections to the front hull, creating spaced armour with an air gap between the new plates and the original hull. The theory is that spaced armour will disrupt shaped charge penetrators and cause armour-piercing rounds to destabilize before hitting the main hull. The result looks like something assembled in a scrapyard. The T-26E4 now has thick armour plates welded at odd angles, external spring assemblies sticking up from the turret, and a barrel so long it makes manoeuvring in narrow streets a geometric puzzle. The counterweight welded to the rear of the turret to balance the gun's weight makes the vehicle look even more ungainly. From certain angles, it resembles a steampunk contraption, a tank designed by someone who'd read the manual but never seen the original. The crews in the 3rd Armoured Division give it a nickname, the Super Pershing, part admiration, part sarcasm, because it's either the most powerful tank America has sent to this war, or it's an engineering disaster waiting to fall apart under combat conditions. Nobody's quite sure which. On April 10, 1945, the Super Pershing sees its first action. The 3rd Armoured Division is pushing toward the Weser River, clearing German resistance from towns and villages in the path. Task Force Wellborn, a mobile combined arms group built around the 1st Battalion, 33rd Armoured Regiment, is advancing along secondary roads. The force includes Shermans, armoured infantry, and now the Super Pershing. The specific details of this first engagement are sparse. Official records note only that the T-26E4 destroyed an unidentified German armoured vehicle somewhere between Weser and Nordheim. No dramatic firefight, no close-quarters tank duel. Just a target, spotted, engaged, destroyed. The gun worked. The tank worked. The external springs held up. The improvised armour didn't fall off during movement. For a prototype, that counts as success. But the real test comes 11 days later, April 21st, 1945. The city of Dessau, on the Mulde River roughly 70 miles southwest of Berlin. The 3rd Armoured Division has surrounded the city and is preparing to assault. Dessau is heavily fortified, garrisoned by German troops who know the war is ending but haven't stopped fighting. The artillery barrage that morning smashes reinforced concrete barriers and defensive positions, but everyone knows the real fighting starts when armor pushes into the streets. Staff Sergeant Joseph Maduri commands the Super Pershing. His crew includes Corporal John P. Irwin as gunner, a loader known only as Pete, and two others whose names weren't recorded in the immediate aftermath. They're told the Super Pershing will lead the advance into Dessau. It's the newest, most heavily armoured, most powerfully armed tank in the division, so naturally it goes first. Maduri's feelings about this assignment can be imagined. He's 20 years old. The war is clearly in its final weeks. Everyone wants to survive to see the end, and he's been ordered to drive the experimental tank with the weird springs and salvaged armour into a fortified German city where any building could hide an anti-tank gun or a Panzerfaust team. At least the armour looks solid. All those welded plates, the extra thickness on the turret, the spaced protection on the hull might actually stop something, and that T26E1 gun can kill anything the Germans have left. If they encounter a King Tiger, the Super Pershing can take it. That's the theory, anyway. The artillery barrage ends. American armour rolls into Dessau. The Super Pershing is one of the first vehicles through the breached defences. Its long barrel makes navigating city streets difficult. Every corner requires careful manoeuvring. The driver can't just swing around intersections. He has to calculate angles, account for the gun barrel extending 11 feet past the hull front. German resistance is fierce but disorganised. Machine gun nests, Panzerfaust teams, the occasional anti-tank gun firing from a concealed position. The Super Pershing takes several hits during the first hours of fighting. The improvised armour does its job. The salvaged Panther plates deflect incoming rounds. The spaced armour on the hull disrupts penetrators. The crew isn't injured. The tank keeps fighting. At some point during the two-day battle for Dessau, the Super Pershing's gunner, John Irwin, engages what he later describes as a tiger. The details get murky here because Irwin's account, written in his memoir, Another River, Another Town, published years after the war, is the primary source. And there's a problem with his story. Irwin claims the Super Pershing destroyed a King Tiger during a firefight in Dessau. He describes a dramatic duel. The Tiger fired first, the round ricocheting off the Super Pershing's armour. Irwin returned fire, his T26E1 round penetrating the Tiger's lower hull plate, detonating the ammunition, blowing the turret off the chassis. It's a great story. It's also probably not accurate. Post-war research by historians, including Stephen Zaloga, found no evidence of King Tigers operating near Dessau on April 21, 1945. The nearest Tiger II equipped unit was the 502nd SS Heavy Panzer Battalion, and they were fighting Soviet forces roughly 70 miles northeast near Fürstenwalde, trying to slow the Red Army's advance toward Berlin. King Tigers were scarce by this point in the war, and their movements were generally documented. None of them were in Dessau. So what did Irwin's Super Pershing actually engage? Most likely a Panzer IV with add-on armour screens, which from a distance could resemble a Tiger. Possibly a Tiger I, the earlier model with the shorter 88mm gun, though those were also rare by April of 1945. Perhaps just a fortified position or an assault gun that Irwin identified as a Tiger in the chaos of urban combat. This doesn't diminish what the Super Pershing accomplished. It fought through 2 days of intense urban combat. It absorbed multiple hits, without catastrophic damage. Its gun destroyed several German armoured vehicles. The external springs held up under combat conditions. The improvised armour modifications proved effective. For a prototype that looked like it would fall apart, the Super Pershing performed remarkably well. By April 23rd, Dessau is in American hands. The Super Pershing survived. Its crew survived. The tank proved that the T26E one-gun concept worked in combat conditions. This matters, because back in the United States, production of T26E4 tanks with properly designed internal equilibrators and improved mounts is about to begin. Except the war ends first. Germany surrenders on May 8, 1945. The massive procurement order for 1,000 T26E4 tanks, authorized in February, gets slashed to just 25 vehicles. These production models are completed at Fisher Tank Arsenal through mid-1945 and into 1946. They feature the improved T15E2 gun with two-piece ammunition, making loading easier. They have internal hydrop pneumatic equilibrators instead of external springs. Their weight distribution is better. They're everything the pilot prototype should have been, but they never see combat. By the time production T26E4s are rolling off the line, the war is over. The tanks get sent to Aberdeen Proving Ground for testing, then to various army posts for evaluation. Some end up as targets on gunnery ranges. Some sit in motor pools until they're declared surplus and scrapped. The original Super Pershing, that ungainly prototype with its external springs and salvaged armour, survives until summer of 1945. It sits in the 3rd Armoured Division's tank park in Germany, gradually being stripped for parts. The unusual armour plates get removed. The external springs are eventually taken off. At some point, the tank is either scrapped or abandoned. No effort is made to preserve it. Why would there be? It was a prototype, a temporary solution to a problem that no longer existed once the war ended. The engineers who created it probably never thought about legacy or historical significance. L.R. Price solved an immediate problem with external springs because internal ones couldn't be designed and installed in 3 weeks. The maintenance crews who welded on the salvaged armour were trying to keep a crew alive, not create a museum piece. The crew who drove it into combat just wanted to survive the war. But the Super Pershing represented something important in how America approached tank development in World War II. To understand why the T26E4 existed at all, you need to understand the problem American armour faced throughout the war. And that problem started in Africa, November 1942. Operation Torch, the Allied invasion of North Africa. American forces equipped primarily with M3 Lee and early M4 Sherman tanks meet German armour for the first time. The Sherman's 75mm gun can handle Panzer IIIs and early Panzer IVs. But the M3 Lee, with its sponson-mounted gun and riveted armour, is outclassed by everything. Worse, American tank doctrine and crew training are inadequate. Crews that learned their trade at Fort Knox discover that textbook tactics don't work against experienced German tank commanders who've been fighting since 1939. The Battle of Kasserine Pass in February 1943 is a disaster. German forces under Rommel push American units back, destroying or capturing dozens of tanks. American tank crews learn brutal lessons. Their armour is too thin, their guns lack penetrating power, their tactics are wrong. They need better equipment, better training, and better leadership. By summer of 1943, improved M4 Shermans with better armour and the 76mm gun are entering production. The 76 isn't dramatically more powerful than the 75, but it's an improvement. Tank crews get better. Training. Doctrine evolves. American forces in Italy and later in France perform competently. The Sherman proves to be a reliable, mechanically sound vehicle that can be produced in massive numbers. By 1944, the United States is building roughly 2,000 Sherman tanks every month. But reliability and numbers don't solve every problem. The Sherman's armour is still inadequate against German 88mm guns. The 76mm gun still struggles against Panther and Tiger frontal armour. American tankers know this. They know they're driving into combat in vehicles that are outgunned and under-armoured compared to what they're facing. Army Ground Forces, the organisation responsible for training and equipping combat units, has a philosophy. They want standardisation. They want mechanical reliability. They want tanks that can be maintained in the field by crews with minimal training. They don't want experimental heavy tanks that require specialised parts and maintenance. They're satisfied with the Sherman. Yes, it has deficiencies. But those deficiencies are acceptable considering the Sherman's advantages in mobility, reliability, and production volume. Army Ordnance, the organisation responsible for developing and procuring weapons, disagrees. Ordnance knows American tanks are technically inferior to German heavy armor. They've been trying to develop a better tank since 1942. The result is the T-20 series of medium tanks, experimental vehicles, testing different transmissions, suspensions, and armament. The T-20 uses a torsion bar suspension, an improvement over the Sherman's vertical volute spring system. It has better armor distribution, but it's still armed with a 75mm gun. The T-22 tests a different transmission. The T-23 experiments with an electric drive system, a radical concept where a gasoline engine powers a generator and electric motors drive the tracks. The T-23 also introduces the turret. That will eventually be adapted for the Sherman, allowing the mounting of the 76mm gun. In 1943, Ordnance starts work on vehicles mounting the 90mm gun. This weapon is already in service as an anti-aircraft gun and as the main armament of the M36 tank destroyer. It's significantly more powerful than the 76mm. A 90mm M3 gun can penetrate 4 inches of armor at 1,000 yards, enough to defeat Panther and Tiger frontal armor under good conditions. The T-25 medium tank mounts the 90mm gun in a T-23 hull with a conventional transmission. The T-26 is basically a T-25 with thicker armor, pushing its weight to over 40 tons. Army Ground Forces tests these vehicles and remains unimpressed. The electric transmission in the T-23 is too unreliable for field use. The T-25's armor is no better than the Sherman's. The T-26 is too heavy for a medium tank, but doesn't have enough armor to be a proper heavy tank. And then the Battle of the Bulge happens. December 1944. German forces launch a massive surprise offensive through the Ardennes forest. Over 400 German tanks, including substantial numbers of Panthers and King Tigers, smash into thinly held American positions. The offensive catches Allied forces completely by surprise. American tank units fight desperately to slow the German advance. The Germans lose the battle. American infantry holds key positions. Fuel shortages cripple German mobility. Allied air power devastates German columns once the weather clears. But American tank losses are staggering. Shermans that were adequate against Panzer IVs get shredded by King Tigers. The 76mm gun proves inadequate against the heaviest German armor at anything beyond point-blank range. After the Bulge, Army Ground Forces changes its position on heavy tanks. Suddenly, they want the T-26 rushed into production and deployed to Europe immediately. The official designation becomes M26 Pershing, named after General John J. Pershing, commander of American forces in World War I. The classification is Heavy Tank M26, not because it's actually a heavy tank by design, but because Army Ground Forces needs a heavy tank for organizational purposes and morale. The first M26 Pershings arrive in Europe in January 1945. 20 tanks, split between the 3rd and 9th Armoured Divisions. These vehicles are technically still designated T26E3, the production pilot version, but they're standardized as M26 during shipment. They're combat trials, Zebra mission vehicles, sent to evaluate performance under actual battlefield conditions. The Pershings perform well. On February 26, 1945, near Elsdorf, Germany, a Pershing-designated Fireball engages a Tiger I. The Tiger gets the first shot, hitting Fireball 3 times. All 3 rounds penetrate the turret, killing 2 crew members. But the Pershing survives long enough for another Pershing to engage the Tiger, and that second Pershing destroys the German tank. This engagement reveals both the Pershing's potential and its limitations. The 90mm gun can kill Tigers. The armor can absorb hits, though not reliably. The tank is mechanically reliable, but it's not invincible, and it's not dramatically superior to the Sherman in most combat situations. Then comes the famous duel in Cologne, March 6, 1945. The 3rd Armoured Division is fighting through Cologne, one of Germany's largest cities. Easy Company, 32nd Armoured Regiment, is clearing streets near the Cologne Cathedral when a German Panther tank ambushes 2 Shermans. The Panther, commanded by Lieutenant Wilhelm Bartelborth, is concealed near the cathedral. It destroys the lead Sherman with 2 rapid shots, killing 3 crew members. It immobilizes the second Sherman with a track hit. Nearby, Sergeant Robert Early commands a Pershing designated Eagle 7. His crew includes gunner Corporal Clarence Smoyer, driver William McVeigh, bow gunner Homer Smokey Davis, and loader John DeRiggy. Eagle 7 receives orders to engage the Panther from a parallel street, hitting it from the side while it's focused on the Shermans. The entire engagement is filmed by Technical Sergeant James Bates from a building overlooking the intersection. His footage will become one of the most famous pieces of tank combat film from World War II. Eagle 7 advances toward the intersection. The Panther's commander senses something and begins traversing his turret. Smoyer, watching through his gun sight, sees the Panther's gun swinging toward them as Eagle 7 enters the intersection. The 2 tanks spot each other simultaneously at roughly 80 yards. Smoyer fires first. His 90mm round hits the Panther's turret. The German tank lurches but doesn't explode. Smoyer fires again. This round hits the hull. The Panther catches fire. Bartelborth and his crew bail out. The Panther burns in front of the cathedral, while Bates's camera captures everything. The engagement takes roughly 15 seconds from first shot to enemy crew abandoning their tank. It demonstrates exactly what the Pershing was designed to do. Fast reaction, accurate fire, penetrating hits at close range. The footage screens in theaters across the United States, giving American audiences a rare look at actual tank combat. But Army Ordnance knows the Pershing's 90mm M3 gun still isn't enough against King Tigers. The King Tiger's frontal armor is 180mm thick at the thickest point. The Pershing's gun can penetrate that armor only under ideal conditions, perfect angle, short range, and using special armor-piercing composite rigid rounds that are expensive and in short supply. This is why the T-15 gun program exists. Development of the 90mm T-15 begins in late 1944 as an attempt to match the King Tiger's 88mm WWII-43 gun. The German weapon has a muzzle velocity of 3,300 feet per second. It can penetrate over 200 millimeters of armor at 1,000 yards. It's the most powerful tank gun deployed in significant numbers during World War II. The T26E1 is designed to match or exceed that performance. At 73 calibers length, compared to the M3's 53 calibers, the T26E1 has a much longer barrel and a much larger propellant chamber. Muzzle velocity with armor-piercing composite rigid ammunition reaches 3,750 feet per second. Penetration capability exceeds 8 inches of armor at 1,000 yards. Testing at Aberdeen Proving Ground in late 1944 and early 1945 confirms the gun's effectiveness. Test shots fired at captured German armor plates show the T-15E1 can defeat Panther frontal armor at over 2,000 yards. Shots fired at a captured Jagdpanzer IV completely penetrate the vehicle, the shells exiting through the rear armor and embedding in the ground behind it. The problem is the ammunition. The T-15E1 uses single-piece rounds, the projectile and propellant case manufactured as one unit. This makes loading simple conceptually, but the rounds are 50 inches long, that's over 4 feet. In the cramped interior of a Pershing turret, trying to maneuver a 4-foot-long shell from the ready rack to the gun breech is awkward and slow. Loaders have to wrestle the ammunition into position. The rate of fire suffers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Ordnance begins development of the T-15E2, a redesigned version using 2-piece ammunition where the projectile and propellant case load separately. This is slower than single-piece ammunition. Each round requires 2 loading actions, but it's faster than trying to maneuver 50-inch rounds in a confined space. The T-15E2 also allows for improved internal equilibrator design, but the T-15E2 won't be ready for months, and the war isn't waiting. So Ordnance makes a decision that's either brilliantly pragmatic or desperately reckless, depending on your perspective. Take the first T26E1 prototype, install the T15E1 gun with single-piece ammunition and external springs for balance, ship it to Europe, see if it works in combat. If it succeeds, accelerate the T26E4 program. If it fails, at least they tried something. This is how the Super Pershing ends up in Germany with external spring assemblies and salvaged armour. The legacy of this decision extends far beyond one prototype tank. The T26E4 program continues through 1945 and into 1946. The production vehicles, 25 of them, incorporate all the improvements Price and the Aberdeen engineers knew the prototype needed. Internal hydropneumatic equilibrators replace the external springs. The T15E2 gun with two-piece ammunition replaces the T15E1. The turret counterweight is better integrated. The armour is properly designed, not improvised from salvaged plates. But these improved T26E4s never deploy. The war ends before they're ready. The Army conducts extensive testing through 1946 and 1947, evaluating the vehicle's performance. The tests reveal significant problems. The gun elevation mechanism has excessive friction. The equilibrator system requires constant adjustment. The traversing mechanism struggles with the turret's weight distribution. The crew ergonomics are poor. The loader has difficulty accessing ammunition racks with the longer T15E2 rounds. Most significantly, the T26E4 is a single-purpose vehicle. It's optimized for long-range anti-armor engagements, but tanks in actual combat spend most of their ammunition engaging soft targets, infantry positions, fortifications, vehicles, artillery. The T26E4's long-barrel, high-velocity gun is overkill for those missions. You don't need a weapon that can penetrate 8 inches of armor to destroy a machine gun nest. The Armored Board, evaluating the T26E4 in late 1946, recommends against adoption. Their report notes that while the gun's anti-armor capability is impressive, the vehicle's other characteristics are inferior to the standard M26. The T26E4 is slower, has worse gun handling, requires more maintenance, and costs more to produce. For a specialized tank destroyer role, it might be worthwhile. As a general-purpose combat tank, it's not competitive. The Army cancels the T26E4 program. The production vehicles get sent to various posts for training and testing, then gradually scrapped or used as targets. The gun development continues under different designations, eventually leading to the T54 gun that would arm later variants of the Pershing and its successor, the M46 Patton. But the Super Pershing proves something important. It proves that when American tank development needs to move fast, it can move fast. 3 weeks from "we need to balance this gun" to "we're shipping it to Europe" isn't normal acquisition timeline. The usual process for tank development in World War II involves years of design, testing, modification, and evaluation before deployment. The T26E, one that became the M26, Pershing started development in 1942 and didn't reach combat until 1945. 3 years of design iterations and bureaucratic arguments. The Super Pershing goes from concept to combat in less than 3 months. That's only possible because ordnance bypasses normal procedures. They take a prototype that shouldn't leave the test range, install a gun that's not ready for production, add emergency modifications in a field maintenance battalion, and send it to war. It's the opposite of proper military procurement. And it works. This philosophy, prioritizing speed and combat effectiveness over procedural correctness, is distinctly American. The Soviet Union follows a similar approach, rapidly deploying new tank designs and modifying them based on combat feedback. The Germans, by contrast, spend years perfecting designs like the Panther and King Tiger, resulting in technically sophisticated vehicles that are mechanically unreliable and impossible to produce in adequate numbers. The Super Pershing's external springs are a perfect example. They're ugly. They're vulnerable. They're a maintenance headache. But they solve the immediate problem, allowing the gun to be balanced and the tank to be combat-ready in weeks instead of months. An engineer prioritizing elegance would have redesigned the entire turret to accommodate proper internal equilibrators. Price prioritizes functionality and just bolts the springs on top. This approach defines much of American weapons development in World War II. The M4 Sherman isn't the best tank of the war by any technical metric, but it's good enough, reliable enough, and producible in sufficient numbers to matter. The M1 Garand rifle isn't perfect, but it gives American infantry semi-automatic fire when most armies still use bolt-action rifles. The B-17 and B-24 bombers aren't as sophisticated as British designs, but America builds them by the thousands. Good enough, fast enough, in sufficient numbers. That's the formula. The Super Pershing embodies that formula in its most extreme form. It's not a good tank by traditional standards. It's awkward, improvised, thrown together from available components. But it's functional. It reaches Europe when it's needed. It proves the T-15 gun concept works. And that's enough. By war's end, the United States has produced roughly 50,000 tanks of all types. Shermans dominate that number, roughly 49,500 vehicles. The M26 Pershing accounts for only about 2,000, and most of those are produced after Germany surrenders. The M24 Chaffee light tank, the M5 Stuart light tank, and various other specialized vehicles make up the remainder. Against that background, one experimental Super Pershing seems insignificant. It's a footnote, a curiosity, a prototype that saw a few weeks of combat and then disappeared. Most tankers who fought in Europe never saw it. Most didn't know it existed. The crews who did see it probably thought it looked ridiculous with its external springs and salvaged armor, but the engineers who worked on it learned lessons that shaped post-war American tank development. They learned that rapid prototyping works. They learned that field modifications can be as effective as factory solutions. They learned that perfect designs aren't necessary when functional designs can be deployed immediately. And they learned that external equilibrators, while ugly, can solve immediate engineering problems when time doesn't allow for elegant internal solutions. These lessons influenced the development of tanks like the M46 Patton, which improved on the 10 Pershing's engine and transmission while keeping the basic layout. They influenced the M47 and M48 Patton, which refined the design further. They influenced the M60, which served from 1960 until the early 2000s. All of these vehicles trace their lineage back to the T26 program, and all of them incorporated lessons learned from rapid deployment prototypes like the Super Pershing. The external spring equilibrators themselves became a historical curiosity. Production T26E4S used internal hydropneumatic systems. Later, American tanks used various types of internal equilibrators, hydraulic systems, spring systems, or counterweight mechanisms built into the turret structure. Nobody ever again mounted large coil springs externally on a tank turret. It was a one-time solution to a specific problem. But photographs of that original Super Pershing, with its rabbit ear springs sticking up from the turret, became iconic. They represent American engineering pragmatism in its most visible form. They say, "We don't care how it looks. We care that it works." And for 3 weeks in April of 1945, it worked. The crew of the Super Pershing, Staff Sergeant Maduri and his men, survived the war. They went home. They didn't become famous. Their tank didn't become famous, not like Eagle 7 and its duel in Cologne. The Super Pershing was just another tank in a war full of tanks, doing a job that needed doing. L.R. Price, the engineer who designed those external springs, returned to his work at Aberdeen Proving Ground. He continued designing tank components and testing equipment. His obituary, if he got one, probably didn't mention the Super Pershing. Engineering contributions rarely make it into obituaries. The first T26E1 hull, serial number 0103292, eventually vanished. Whether it was scrapped for metal, left to rust in a European salvage yard, or somehow still exists in a forgotten corner of some depot, nobody knows. No museum preserved it. Nobody thought it was worth preserving. It was just a prototype, a test bed, A vehicle that served its purpose and then became obsolete. But every time historians discuss World War II tank development, the Super Pershing appears. Every time someone asks how American tanks evolved from the Sherman to the M26 to the M46 and beyond, the T26E4 program gets mentioned. Every time someone wants to illustrate the difference between British tank development with its emphasis on technical perfection and American development with its emphasis on rapid deployment, the Super Pershing becomes an example. Because it represents a philosophy that won the war. Not any single battle, but the overall conflict. Germany produced roughly 26,000 tanks during World War II. Many of them were technically superior to their Allied counterparts. Panthers, Tigers, King Tigers, these were formidable vehicles when they worked, but Germany couldn't produce enough of them, couldn't supply them adequately, couldn't replace them when they were lost. By 1945, German factories were struggling to produce 500 tanks per month. America produced 50,000 tanks. Most of them were good enough. Some of them, like the Super Pershing, were improvised solutions to immediate problems. But they kept rolling off production lines, kept shipping to Europe and the Pacific, kept replacing losses. When a Sherman got destroyed, another Sherman replaced it within weeks. When a Pershing needed parts, the supply system provided them. The Super Pershing's external springs symbolize that industrial advantage. They're not the best solution. They're the solution that works right now with available materials and manufacturing capacity. They're good enough. And in war, good enough delivered today beats perfect delivered next year. This is the story of one tank, one prototype, one engineering compromise that looked absurd and worked anyway. It's not the story of the decisive weapon that won the war. It's the story of thousands of decisions, thousands of compromises, thousands of good-enough-for-now solutions that collectively created an overwhelming material advantage. The Super Pershing fought for 3 weeks. It survived. Its crew survived. The gun worked. The springs worked. The improvised armor worked. And engineers back in the United States learned that when the situation demands it, you can take a standard tank, install an experimental gun, balance it with external springs, weld on salvaged armor, and ship it to combat in less than 3 months. That knowledge, that institutional confidence that rapid development works, shaped American military procurement for decades. The philosophy that speed matters more than perfection, that functional solutions beat elegant solutions if they arrive faster, that good enough now beats perfect eventually, these became foundational principles. The Super Pershing proved them correct, even if it looked ridiculous doing it. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.